on?
Yeah.
All right, great. So let me pull up the slides. Okay, welcome back. This is week 4 of the AOE CAD 2 class. I'm Eugene. You saw me a couple weeks ago, and I'm back. And this week we'll start off by talking about the homework assignments from last class. And so one of the things Jack had to do in preparation for this class was to complete the assembly of the universal joint. And so hopefully all of you have managed to do that. If I could get like a show of hands, just if you did. And if you had some problems, also now would be a good time to bring it up and we can work through some of these things together if needed.
I need help with mine.
All right.
I didn't like have any time to make it.
Sorry, I couldn't quite understand you.
I didn't have any time to make the joint.
Okay, that's also understandable. I guess who was the first person who said they might need some help?
I did.
Okay, so I guess we'll start off. If you want to screen share with us, we can take a look at your assembly.
Since so he posted the photo of like how to do it, but I couldn't access the photo, so I haven't done it.
All right. For future reference, I think you should be able to access the slides on Google Classroom, and so the picture will have been at the bottom of the slides. That's okay if you couldn't find it though. So if you go back to Onshape, it's pretty straightforward. So you have your cross there, right?
Yeah.
What you'll want to do is make a revolute mate with the circle in the inside of the clevis fork. So just make sure the end face of that matches up with the outside face of one of the clevises.
Where do I attach it?
So do you see the clevis, like right, that outside face that you were just hovering over?
Yeah.
If you click on the circle where that hole is, it should be able to mate to that. So you can imagine that the little cross will be inside the fork.
Right here?
Yeah. All right, so that's your first mate. And now the other mate is just exactly the same thing with the remaining 2 parts of it. So you take I think you selected something you didn't want there. You take just the outside face of the other fork and you pick that other part of the cross. And if you accept that and solve it, it should work. Yeah, so that looks good. I see in the chat someone's asking for the class code. I believe you will have received it in an email, but I'll make a reminder to myself at the end of the class. I'll find the code and put it in the chat. So is everyone else good with their universal joint assemblies?
I'm not, because I didn't have time to do every part of the homework, and I also couldn't access the thing, so I didn't do the like base thing for the U joint.
Yeah, me too. Like I only was able to make like one fork. I couldn't make the joint.
Okay, so Drew, do you have the parts made, or and you just need to do the assembly?
I don't have the parts made, because I didn't have time to make it.
Okay. I think if it's not an assembly issue at this point, I think we'll move forward with the class for today. You should be able to do like the things that we're doing today, even if you haven't assembled the U-joint. And you had practice last week with the do nothing machine, right?
Yeah.
Okay, so for this class, we'll just have to go on with it. If no one else has any assembly questions for the universal joint, then I'll move on. So the other thing that Jack, I believe, asked you to do for this week was to model this base plate. And so at this time, I'll take any questions or problems. We can look at some problems you had with the base plate together. And so just speak up, tell me if you finished it, if you didn't finish it, what your status is.
I finished it, but I don't know if it's correct, my dimension. So are you able to check it for me?
Sure, we can do that. Why don't you share your screen?
So this is my this is my first sketch I created. Oh, is this better?
Yeah, that's better. All right, let's see. What part do you think might be, or what part do you want me
So
to
I
look
don't
at?
This is the I don't think this is the problem. I think it's the second circle. I don't know if this is 0.375.
That looks right to me. So the largest diameter of the hole should be 375.
So are these correct?
Looks right to me.
Huh?
It looks right to me.
Okay, thank you.
All right, anyone else want to talk about the base plate?
Actually, I don't think I meant that base plate. I meant like for my U joint. I did the U joint nozzle and I did the cross thingy, but I didn't do the thing where I'm supposed to slide everything in.
Okay, right, I understand. So did you also not do this base plate?
Wait.
Oh, sorry. Were you able to CAD this one?
Oh no, because I couldn't get onto this. Yeah, I just couldn't. Or
Were you having a problem with Onshape?
no, I just couldn't. It's hard to explain, but I couldn't get on. So
Okay, we'll work through your, we can work through that after class. All right, suppose, can you log into Onshape right now? Because we'll be working on something together during the class period. Alex,
yeah.
are you able to use Onshape right now? Because we
Yes.
will, okay, that's all that's needed at the moment. So for everyone who couldn't finish the U-joint, I guess, as a blanket statement, just focus on this assignment and moving on. Like just start with the base. And if you really want to, or you have extra time, you can do the U-joint, but this one is more important since we will be using it in the coming weeks. So if no one else has any comments about the base plate.
So I should create a new document and create the base plate thing.
Right, just make sure you have that for next class.
Okay.
Anything else about this baseplate before we move on? All right, so now for the topic of this week, which is looking at importing parts into Onshape and parts catalogs and things of that nature. And so the first topic that we'll be talking about is a catalog called McMaster Car. And so this is something called a part catalog. It used to be this really big telephone book-like book where you could open it up, you look for whatever hardware or machinery parts you'd want, and then you could order it. And these days, it's all on a website. And if you look through this website, almost every part that you can think of, whether it's bolts or nuts or screws, bearings, replacement parts for your bikes, if you have bikes, things like that are all available on McMaster. And so it's often used in like engineering for selecting various standardized parts for you to use in your designs. And one really cool thing about McMaster is that it often provides a CAD model of the part in its product detail. And so when you're designing a part that has a lot of like screws in it, there's no need for you to model every single screw by yourself because it's a standard part that's always the same. And so what you can do is you can download the screw or whatever it is from McMaster, and that's what we're going to look at today. So if you want to just type in like www.mcmaster.com, I'll also put that into the chat for you. It'll take you to this website. And so as you can see, there's a lot of different categories. And I'll give you just a minute to look through this stuff on your own. Let's say, for instance, that I'm designing something and I need a screw. So what I would do is I'd come here, I click screws and bolts. Let's say what I want is a socket head screw. So I'd click socket head screws. Maybe I want this black one. And it would take me to this huge list of all these different kinds of screws. So how do I know what kind of screw I want? The first thing that you might look at is the thread size. And this is something that will come up shortly, but just to give you a very brief overview of how screws work, most standard screws are described by two numbers. And so here in this list, you can see that there's a long list of one number dash another number. And so what this means is the first number describes like how wide the screw is. That is like how big a hole you need to put that screw into. And the second number describes the threads per inch. And what that means, if you look at the screw, there's two parts, right? There's the head, which is where you put the screwdriver in. And then there's the long body. And on that body, there's that spiraling part. And those are called threads. And so the second number just describes what kind of threads that screw has. And so for my part, I can just scroll down. Let's say that I wanted a 6-32 screw. Then here, once I scroll down enough, I can see the entire selection of every 6-32 screw that's available on McMaster. And I could just pick from these the length that I want. And that's enough for me to land on a single unique screw. And so let's say that I want this 1 1/4 inch fully threaded 6-32 screw. And I want to put this into my CAD model. What I do is I click it once. I can click on the product detail. And not every single product on McMaster has this, but a lot of them have this CAD icon, which means that you can download the file. And so what you would do is you click this little drop down and you pick step, and you can download the file that way. So I'm going to be doing a longer demonstration of importing the part into Onshape, but for the moment, just take a moment to look around, explore like the different types of parts you can buy. There's a lot of really crazy stuff here, and I'll just let you explore. If you find anything really cool, feel free to type it in the chat and I can take a look. So out of curiosity, like how many of you guys have used hardware like screws and nuts and bolts before for like assembling furniture or something like that? All right, and like maybe some of you guys like to ride bikes, and so you've had to like fix things on your bike or get replacement parts. Yeah, I see some thumbs up. So that's McMaster for you in a very quick overview. And now we'll go on to our example where I show you how Onshape, where I bring Onshape into this and how you can get these models to make something interesting for yourself. So take a look at this little assembly, this gizmo on the right. So you can see that if I asked you to just model this on your own, it would take a lot of effort. You can see that there's a lot of distinct parts on it. There's a lot of different shapes with a lot of different features. But the good news is if I wanted to make this exact assembly, I don't actually have to model any of this myself. And that's because I'm using a lot of standard parts. And so there are 3 parts involved here. One of them is the shaft, which is this cylinder with a rectangular hole dug in it, this long channel. The second part is a key, which is a small rectangular prism. You can see it in the middle, sitting in this channel. Just a little square of it is visible. And the third thing is the shaft collar, which is the light gray circular object with the 2 screws on the sides. And each of these parts I found on McMaster. So you can follow along, you don't have to. I'm just going to show you how I would download each of these parts. So as before, I find myself on this product page. It has a little CAD symbol, so I know that it offers a model. I click the dropdown and I click step, and I can download that. So just like any other file, you can save it into any folder on your computer, save it into downloads maybe. And now that file, the 3D model of this shaft is now on your computer. And so now we'll go on to Onshape. At this point, everyone should open up their Onshape if you haven't already done so. I'll just make a quick demonstration. So I've created a new document. Nothing in it so far. And let's say that I want to put that shaft into my document. What I can do is insert a new element using the plus sign. And then instead of creating a part studio or something, I can click import. And then from import, all I have to do is navigate to the folder where I saved that file. And if you open that file, it'll bring up this dialog option. Just the default settings are fine. If you press OK, it'll take a couple seconds, but it imports the part. And now I have that shaft that I saw on McMaster, this 3-inch long shaft with the keyway channel is now in my document. So I can make an assembly with this. I could modify this if I wanted to. It's here. I'll demonstrate that one more time for the shaft collar. Again, you go to the product page, you click download. Now this one is a bit different because the shaft collar, as you saw, actually consists of multiple parts. It has the screw on the side and it has the 2 C-shaped halves of the collar. And so when you import something like that, where the model has multiple parts in it, you have the option of creating a composite part and importing multiple or non-solid bodies. What that means is that if you're importing something that has multiple distinct bodies in it, like the screw and the 2 C halves of the collar, then it just imports that all together as one body, or if I don't check it, as separate bodies. And so that's just something to keep in mind if you ever do something like this on your own. But if you give it a second, it'll show up. since I checked yes on that option, this whole thing now came in as a single body. So everything's attached to each other, which is what I wanted. All right. So that's McMaster. If you want, you can play with that in your own time. And it's very useful. I use it all the time in my own school classes and for my own projects. So if you ever get into that kind of thing, it'll be very handy. The next thing I want to show you is a different kind of website. This is Thingiverse. And so if you're interested in 3D printing or hobby making of things, then this is a good website where a community of people who are also hobbyist 3D printers or model makers submit things that they've made for everyone to enjoy. So I'll put the link of this into chat as well. So this is a bit different from McMaster, where the parts that you find aren't necessarily standard hardware like screw or bolts or bearings. Instead, it's just things that people wanted to make. There is a search option. And so I'll just give you another moment to look through this on your own, see what you can find. And I'll demonstrate how you can download models. Let's say that I really like this statue. I clicked on it and it brings me to this page, and then I can download all the files. There's a short countdown. And after that, it prompts me to download that file, which you save like any other file onto your computer. What's often the case is that it gives you a zip file. And so, as you might know, you can just right-click it and extract all. And it puts the file onto your computer. And so just like we did with the McMaster screw, what you can do is import that part by navigating to it and selecting it. And once it finishes, that part will also just be in your document. And so if that's something you wanted to 3D print, that's how you would first get it onto your Onshape. So at this point, is everyone good with McMaster and Thingiverse, what these websites are for? You've all been able to take a look at it? Just let me know, type yes in the chat or nod. All right. Next thing we're going to talk about is how we'd export files for 3D printing. And so once you make a model in Onshape, you need to get that model onto your 3D printer. And so we'll talk about this more in depth in the later classes, but for now, we'll just go over the export function. So usually the file type that you would save your model as is called .stl. And so let's go to this statue that I downloaded a second ago. Here it is. And let's say that I want to move this onto my 3D printer. What you can do is you right click on that tab. You can click export. And in the format, you just pick STL. You can adjust this if you want, but we'll talk about that in the future. And you can just download it. And that'll put an STL file of the model that you made onto your computer. And so that's one of the first steps in the 3D printing process. Having gone through that, we'll now move on to introducing the second project in this class, which is the oscillating engine. So the objective for this class session, hopefully we can model 2 more parts for this engine. Last week, Jack gave you the first part, which is the base plate. And here's a little picture of what that engine would look like if you actually went into the machine shop and you cut up and drilled some metal to match those drawings. And you'd have this working little engine in action. And so we'll begin today with the cylinder. Again, we're modeling from a drawing, as we talked about in previous classes. If you've already made your base plate, I want you guys to work in the same document that you made the base plate in. Here, I'm just creating a new document for the demonstration. And the part that we're doing is the cylinder. So I want you guys to follow along as I start modeling this, but just taking a look at this drawing, can anyone tell me like what's the first step that they would take if someone told them to model this? It's like, what feature, what sketch would you first make? See, Peyton, you have your hand up.
Yeah, so first I would just draw a rough sketch of the top left image, and then I'll dimension it from there.
Okay, can you elaborate what you mean by like your rough sketch?
So I would just draw like from the midpoint, I would just draw not from midpoint, you draw like a line on the x-axis to the left a little bit, and then go up from there, and then draw like a small like a little angled line, and then I would mirror that, and then I would draw a line connecting to make like a triangle, like a roof triangle-ish.
All right, yeah. That seems pretty reasonable. And let's think a bit about like what this feature represents, right? So Peyton pointed out this angled like slope in the dashed lines. And so if we remember from our drawing class, what do the dashed lines represent? Can someone tell me? Maybe in the chat you can type out what a dashed line is.
Does it mean it's cut in half?
I see someone says symmetry, right? So the blue dashed line with the irregular dash dot kind of thing, that is a symmetry line, which indicates that that's a line of symmetry. And in addition to the blue dashed line, there's also this black dashed line, right? And what does that represent? Is that something that we can see directly if we're looking at the real object with our eyes? I see in the chat, hidden from view. And that's exactly right. So that indicates that this geometry, this dashed line with the slope, is hidden. And what can it be? If we look at this top view, we see this solid line that's a circle. And that tells us that there's a hole inside of this block and that the hole tapers into this cone at the end. And the reason it does that is because when you're making holes in real life, you use something called a drill bit. And the way that most drill bits are shaped is kind of like your pencil, where the tip of it is tapered into a point. And so if you drill a hole into a block with a drill bit like that, you'll end up with a little point in your hole at the end. And that's what this drawing is trying to show. Otherwise, I think we've covered like what this object pretty much looks like. It's a square block, and it's got 3 holes in it. This one big hole that goes almost all the way through the block, and there are these 2 smaller holes. Do you have a question, Peyton?
Do we draw this on Part Studio too?
Yes, you just want to make a new Part Studio in the same like document that you made your base plate in. One more thing that I want to point out before I start joining you and modeling this is you can see here that the call out for this hole is 10-32 thread 0.25 deep. And so do you remember something I was talking about earlier when I was talking about the numbers, a number dash another number and threads, what that represents, or just what kind of part that's for? To give you guys a hint, something we looked at in McMaster. Yeah, Peyton.
I think the number on the left was like how wide the circle would be, and then the one on the right would be how long the nail is.
Yeah, that's pretty much it. The number on the right represents like the threads that go along the length. So it's like how tight these threads are. But yeah, that's very good. I was just looking for an answer like a screw, but I'm glad that you remembered that. So yeah, at this point, I'll start making the model. You guys can follow along or go at your own pace if you've already started. But the way I'll go about this is start with a little square. I remember from my drawing that when you look at it from the top, it's a 1x1 square. So I just made my 1x1 square. And then I want to extrude that square. And to know what height I want to extrude this to, I look back to my drawing and I see 1.875 as the total height of that block. And that's what I'll make. So now I have this block that makes up the bulk of the part. Whoops. And now I have these 3 holes. I'm going to start with the biggest hole. And I'm going to teach you something perhaps that you didn't know before, which is how to easily make that drilled feature with the pointy tip in one feature. Yes, Peyton?
Where are the dimensions? Like, is it in Google Classroom?
Oh yeah, the drawing is in Google. The slides are in Google Classroom. There's also this PDF file that should be in Google Classroom as well. And if you scroll, you can see a bigger version of the image. I guess at this point, I should probably get the Google Classroom code for Andrea. Is that your question? Andrea?
Wait, how tall was it again?
1.875.
Okay.
Do you need the Google Classroom? Does anyone need the Google Classroom code right now?
I don't have it right now.
Okay, I'll look for it shortly. Peyton?
You said the height was 1.87 for the rectangle, because but I don't. It doesn't. I think because like it looks like on my screen that 1.87 is like not the rectangle. It goes a little past it.
Right, 1.875 is the dimension. If you look at my screen, I've highlighted that dimension. And so right now I'm just modeling the very big rectangle here. Do you agree that the height is 1.875? Okay. Give me 1 second and I'll find the Google Classroom code. All right, I'm going to paste it into the chat. So Andrea and whoever else needs it. There it is. The PDF with all the drawings is available in the Google Classroom, as are the slides, which also have the drawings on them. So the next thing I'm going to do is I'm going to work on that this large hole. And so I'll make a sketch. I'll pick this top square plane. And on this plane, instead of making a circle, what I'm going to do is I'm going to pick this point tool. And I'm going to put a point, a little blue dot on my sketch. And if I look at here, I know that the center of that circle, which is what I made that dot for, is 0.5 and 0.375 away from the corner. So I click the dot. I click
Wait,
this.
that kind of looks like a square to me. For me, I got a rectangle.
Do you mean this?
Oh, oops. Yeah, I couldn't see
Okay.
that.
Yeah, sorry. So when you have this rectangle, I just want you to make a new sketch on this square. So you're right that it was a square. I was just looking at it head on. Andrea, do you still have a question, or is your hand raised from before? Okay. So as we were doing, you click the line, you click the dot with your dimension tool, and you make that 0.5.
Wait, where did you make the dot? Wait.
So in your toolbar, there's a tool called point. It looks like a small blue circle, and it's
Yeah.
between the spline tool and the text tool.
Okay.
You can just click on it once, then click on the square somewhere, and it should place a dot.
Okay.
And let me know if that works.
Yeah, it works.
All right, so I just want you to dimension it as we see in the drawing, 1/2, 0.5 away from the top, 0.375 or 3/8 away from one of the sides.
Wait, what were the dimensions?
0.5 and 0.375.
0.5. Wait, 0. And 0.375.
I see. I'm not too sure about that right now, but we'll address it after the class. For now, could you just follow along with what I'm doing?
Okay.
And I'm sorry about the Google Classroom issue, but we'll make sure to look at it.
I have a question.
Yes.
Can I share it?
All right.
For this one, I didn't get how to dimension it.
That's 1 inch and 1 inch.
No, I didn't get like the square part.
What do you mean?
I didn't get like that. You have to put a circle in the middle and then you have to dimension it like 0.375.
Sorry, it's hard for me to hear what you're saying.
I couldn't. I don't know how to do the dimensioning of the 0.
Okay. Okay, I see. So first of all, you can see that your square isn't fully defined yet because it has some blue lines, right?
Yeah.
And so do you know what's not fully defined about this?
The distance between this to this.
Try clicking it and dragging it and see what happens. Or escape out of your dimension tool. Click the line and just drag it. So the position of that square was what was not fully dimensioned.
Oh.
Okay, and now it's good. It's all black. Now what you do, I want you to, you can do this in this sketch too, that's fine. Click the point tool, which is the blue circle. It's next to the spline tool. And just click it. And I want you to dimension that so it's 0.5 and 0.375.
Thank you.
All right. So at this point, we have this rectangle. And what we can do is we're going to use this tool called the hole tool.
How much do I extrude it by again?
1.875. So the hole tool gives us a lot of different options. ANSI, ISO, DIN, and PEM are all different standards. So if you go to your hardware store and look at various screws and rivets and bolts, they follow these various standards. But for now, we're just going to click custom. And we look to our drawing. Here we see that the drawing has two numbers that indicate the diameter of the hole. And what that is a tolerance. So it's telling the person who would make this object in real life how accurately they need to make it. And so they want you to make it no less than 0.500 inches and no more than 0.501 inches. For us, we don't really care about that since we're not making this in real life. So I'm just going to put 0.5 for the first part of this hole tool. And for the second part, I want the depth of the hole up to this flat part, which is called out as 1.625. And that's the dimension that I can put in here. For the sketch points to place holes, that's asking you for a point. And that's why I made that point on the square earlier. So you can click that point. And at that point, you can just click the check mark and it'll make the hole. Peyton?
For sketch, what did you do for sketch number 2?
For me, sketch number 2 was just placing the dot. Some of you might have done it in sketch 1, which is also fine. But my sketch 2 just contains one dot and that's it.
And then after you're done with the sketch 2, where do you get the hole? Like where the hole is?
Right, so once you have that sketch, you click the hole tool, which is in the middle of your toolbar. It's next to shell and pattern. And if you click hole, it brings up this dialog box that I have open right now. Are you able to find it?
Yeah, but I don't have the two. I don't have like, I only have one like over on your screen next to the 0.5. You have like 0.5 and under it you have 1.625. I only have the, I don't have two of them. I only have one.
Did you make sure to change this to custom? Maybe I can take a look.
Like I only have right here, I only have one, where you had two, like one up here.
Okay, so that's because you selected a through for your second drop-down option. And what through means, it's going through everything. And so you don't need to specify a depth if you have a through hole because it goes through everything, right? So if you click the through, little drop down next to through, and you click blind, now it's blind. So it doesn't know how deep it has to go. So you need to tell it how deep it has to go. And that's how you bring up the second option.
Okay, thank you.
Is everyone else good with the hole tool? All right, so I'll make that feature and you can see inside, it has a little conical shape. And that means it's accurate to what is made in the drawing, since it has that little taper to the point to represent the drill bit. Now there are 2 more holes that we need to make before we're finished with this part, and so we'll make those now. So this is a part where you might have to be kind of careful. First, look directly on the top of your part. And you can see that the hole that we just made is closer to one side than the other side, right? So we want to draw on this face where it's farther away from the hole. And if you look at the drawing again, you can see what I mean by that, where the holes go through the thicker part here. So if you look at it this way, this is what it should look like. And I just want you to make a sketch on this rectangular face. Are y'all good with picking the next face to draw on? So as before, on the sketch, I want to eventually make 2 holes in this plane. And so I click the point tool again as before. I click once to make 1 point. I click again to make another point. And that's what I have. So if we're good up to here, I'll start dimensioning it. As someone pointed out before, there's a blue line that indicates symmetry. And so I know that these holes must be centered. And so what I'll do, I'll use the dimension tool. And I know this is 1 inch wide. So half of 1 inch is 0.5, and that'll make it symmetric. So I click the point, I click this line, I do it to 0.5 inches. I do the same thing for the other point. I click the point, I click the line, and I make it 0.5 inches. Is everyone good up to here? All right. So finally, we'll do the last 2 dimensions, which determine where the points are, like vertically. And so if you look carefully, the opening of the hole is actually at the bottom of this block. And you can tell because the little triangle, which is the bottom of the hole, is up here. And so we're dimensioning from the part where the hole opens. The first dimension is 0.875. And so from where the hole opens, which is here, I click the line, I click the point, and I put in 0.875. The next hole, again, it's dimension from the opening, 1.5 inches. And so I click the point, I click the line, and I put in 1.5. And that should fully define your sketch. And let me know, just type yes in the chat or give me a thumbs up if you're good with this. All right, seems like we're all good. So what we're gonna do now is something a bit different. We see here there's the 1032 thread, 0.25 deep. This is where the hole tool really comes in handy, because it allows you to make standard sized holes like a 1032 with just a few clicks. So again, hole tool, we want a blind hole, not a through hole. And we want to click ANSI. We want a clearance. And then for the size, we want to click number 10. Sorry, or Peyton?
How come your dots are lower than my dots? When I go to sketch 3, I did the same dimensions, but mine's higher than yours.
Do you want to show me?
Yeah. Right here. Oh, oops. But like yours are down
so
here.
that's a quick fix. it's not 0.5, but 1.5 for the dimension of that hole.
Oh, okay,
Yeah.
thank you.
I guess miscommunication there. And sorry, it's not actually a clearance hole. I misspoke there. It should be a tapped hole. So I'll run through it again. Use the hole tool. You want a blind and C tapped number 10 hole. And you want 32. And that's what the 10-32 means in the drawing. You can leave that at 75%. And so it already automatically fills in for you this diameter based on these numbers that you put in. And all you need to specify is the depth. And so if you look at the drawing, it says 0.25 deep. That means the whole depth that you want to make should be 0.25. And the hole that we're doing right now is the one that's closer to the opening of the hole. So kind of the one in the middle. So you select that one, and that's the hole you want. So let me know if you get this. Let me know if you get to this point or if you have any problems. Again, an ANSI tapped 1032 hole, that's 0.25 deep. If we're all good, I'll resolve the feature. And we have our first hole. Now, one thing that happened is since it made our hole with that sketch, it made our sketch disappear. What you want to do is if you go over to your feature tree on the left and you click the eye, it'll make the sketch reappear. So you can see your sketch again with the 2 points. And we're going to now make another hole with our hole tool. Again, we're going to make a custom hole. Since the diameter of this is 0.125. So we'll make the diameter 125. And we'll make the depth 0.5 inches. And if you look inside, you should be able to see the hole come out through into the hole. So is everyone good up to here? Peyton?
Well, what does it mean by merge scope?
So merge scope refers to whenever you make a new feature, you have a lot of, I guess to explain it, let's take a different example to explain what scope means, right? So let's say that I make a square and I extrude it into this block. So that makes my first like body, so to speak. And then let's say like right next to it, I draw another square and I extrude that into a block. Now I might want those two to be one part, right? Just together, one part that looks like two blocks, kind of like a square snowman. But I might also not want that. I might want those two to remain like distinct things. And in that case, the scope would be different because if I want to make them one thing, the merge scope would be to part one, where part one is that first extrusion that I made. And so with every feature, there's like a possibility that what you're making might not be intended to become a part of what it's on, so to speak. And so merge scope allows you to clarify that, but we don't need to mess with that. Peyton?
Just wondering, on the engineering side, how do we know how deep it is?
Oh, okay, good question. In this case, I knew that a blind hole of 0.5 inches would go far enough to enter this hole. And if you look at the drawing, it doesn't specify how deep it is because it shows in this view that it goes into this hole, right? So A different way to do this would have been, instead of making a point drawing here, I could have made a circle drawing that's 0.125 inches in diameter. And then I could have done an extrude cut. And what an extrude cut allows you to do, if you remember, is an up to next. So I could have just selected the cylindrical face here as my up to next, and it would have created an extrude cut of 0.125 in diameter up to that surface. The 0.5 was just a number that I knew was big enough to reach this hole. So it wasn't an explicitly stated dimension, but there are multiple ways that you can CAD any object, and this is one I demonstrated since we're using the whole tool a lot, and to just show that as much as I could. Is everyone good with this object? If you don't like seeing these dots, you can go back and hide sketch 3, clicking the eye again. But yeah, that's the completed cylinder. Every feature that's on the drawing has been made in your model. And so in the future, if you see a drawing that indicates something like 10-32, you know how to make that. You use the whole tool, you click your standard, and you click the numbers, and it makes the feature. The original plan was to model the crank wheel as well, but that may have been over ambitious. The plan for the next few classes is to continue to model more parts of this engine. And so if you see this little square thing here, that's what you just made. And yeah, as we go on, we'll be making more of these parts. For next week's class, I want you to model the piston. So on Google Classroom, there's a PDF with all of the drawings for this engine, and the slides are also on Google Classroom. So the drawing is here. The part is called piston, and it looks like this. Where there are tolerances on the drawing, which is what I talked about before, where there's two numbers stacked on top of each other, I just want you to use the larger number. So for this one, where it says 142 and 144, just pick 144 as the dimension to make that hole. And likewise for here, the outer diameter has a 0.4994 and a 4967. You can just pick 4967 to dimension that hole. And so for next class, first of all, if you haven't done the base plate yet, I want you to do that one. And for next class, if you could model the piston, we'll be using that in the future. And so in terms of content, that wraps up today's class. If anyone has any questions about CAD or homework or similar topics, I'll be happy to take them now.